Okay, let's start the test review for AQR, sections 11 through 13. Number one, what's the probability of getting exactly two heads, getting heads exactly twice when you flip a fair coin 4 times? Okay, so if you flip a fair coin 4 times, just as an example, you might get heads the first time, tails the second time, heads the third, and tails the fourth. That is one of the possibilities. And that is one possibility where you have flipped and gotten heads twice. Now, how many total possibilities are there, how many total outcomes are there when you flip a coin 4 times? Because we want to do probability, and we need to put how many ways are there to get exactly 2 heads divided by how many total ways are there for 4 coins, or for a coin to be flipped 4 times. So how many total ways are there? Well, how many ways are there for the first times the second times the third times the fourth? 16, 2 to 2 is 4, 2 to 4 is 8, 2 to 8 is 16. So 16 total ways. How many ways are there to get exactly 2 heads? Well, you can have head, head, tail, tail, head, 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 tail. I'm sorry, head, tail, and then head, tail, tail, head. Then you can move the head to the second flip and get tail, head, head, tail, tail, head, tail, head, tail, tail, head, head, and that may be it. I believe that's all. So that gives us 6 out of 16, which reduces down to 3/8 probability. What a probability of getting 0 heads when you flip a fair coin 4 times. Okay, again, there's 16 ways that a fair coin flipped 4 times could land. 0 heads mean all tails, and that can only happen one way. So the probability of getting no heads is 1 out of 16. The probability of getting only 1 head when flipping it 4 times, well, that 1 head could go any one of 4 places. And the other 3 places would be tails. So that would be 4 different ways out of, again, the 16 total ways, which reduces to 1/4. Number 4, what about getting all heads, all 4 heads in a row on the first try using a fair coin? So 4 heads in a row, there's only one way that can occur out of 16 total ways that are possible. So again, 1 out of 16. Now we switch to odds. Odds of drawing 1 card and getting a spade from a standard deck of 52. So we need to know how many spades are in the deck. There's 13. So there's 13 ways, if you win when you get a spade, and there's 13 ways you can win out of the 52. Well, so the rest would mean if you did anything else, that would mean drew anything else besides the spade, you would have lost. So 52 minus 13 is 39. So there'd be 13 ways to get a spade, 39 ways to not get a spade, which should add up to your total of 52 when you're doing odds. What's the number 6? What's the odds of drawing 1 card and getting a face card, jack, queen, or king? Well, how many face cards are there? Well, there's 3 of each suit, and there's 4 suits. So that means there's 12 total face cards. So there's 12 out of the 52, which means the rest would be 40. We should reduce that down to 620, which reduces to 310. Both of those are divisible by 4. The ratio should be 3 to 10. That would be the odds, 3 to 10. Black Beauty, what are the odds against, if the odds against the horse Black Beauty winning a race are 7-1, what would be the probability that Black Beauty would win the race? So the odds against means lose to win. So there's one way to win, 7 ways to lose. That gives us 8 total ways. So if we want the probability that they will win, we need, how many ways are there to win? 1. And how many total ways are they saying? 8. So there's a 1 in 8 probability of winning, which is equivalent to the odds against being 7-1. Number 8. Now there's a game, we consider a game in which 2 fair coins are tossed. The payoffs are as follows. If it lands both heads, you win $3. If it lands both tails, you lose $2. If it's one of each, you only lose $1. What is the expected value, or in other words, the average amount won or lost per play over time? So what's the probability of getting both heads? Well, how many ways can 2 coins land? Well, the first coin can land 2 ways, the second coin can land 2 ways, so 2 times 2 would be 4. Only one of those ways is at both heads. So the probability of landing both heads is 1/4. And you'll win $3 if you land both heads. On the other hand, you will lose $2 if it lands both tails, which is, both tails is also a 1/4 probability. And you will also lose, but you only lose $1 if it's one of each. So what's the probability of being one of each? Well, it could be head, tail, or tail, head. So that's 2 out of your 4, or 1/2. Now, when you add or combine all of these, the amount that you get is the expected value. So if I simplify this fraction, I've got 3/4 minus 2/4, which is 1/4, and 1/4 minus 1/2 is going to be a negative 1/4, and that is the dollar amount, which is 25 cents. It says if you play this over and over, on average, you will lose 25 cents per play. You don't want to play this game. You will not win money unless you get lucky, the very first roll, and the very first flip, and get both heads. Then you should walk away. Number 9, what's the probability of rolling a 7 or an 11 when you're rolling a pair of die? Well, the probability, how many ways are there for 2 die to land? 6 for the first die, 6 for the second, so that's 36 ways that 2 die could land. How many of those ways are 7, and how many of those ways are 11? So we looked, and there are 6 ways to roll a 7. 2, 5, 5, 2, 1, 6, 6, 1, 3, 4, 4, 3. Plus, how many ways are there to roll an 11? Well, there's a 5 and 6, and a 6 and a 5. So there's 2 ways. So that becomes 8 out of 36, which reduces to, both are divisible by 4, which reduces to 2/9. That is your probability of rolling a 7 or 11. What's the probability of rolling a double? Well, how many ways are there to roll a double? 6. Double 1, double 2, double 3, double 4, double 5, double 6. 6 ways out of 36 total ways that it could land reduces to 1/6. What's the probability of rolling a 2, also known as snake eyes? Well, how many ways can you roll a 2? Only 1. 1 way out of 36. 1/36. That's your probability. Number 12, you have money invested in a stock portfolio. Here are the following allocations. And we want to find the average or expected annual rate of return, the rate of return. In other words, I want the average amount, average percent of return when the chances, or when the percentages of my money are distributed that much. So 25% of the time, 0.25, or 25% of my money is at 11%. 30% of my money is at 8%. 35% of my money is growing at 14%. And 10% of my money is growing at 8%. So when you add all of that up, you'll get the average percent rate of return on the entire portfolio. I'll let you go ahead and do those calculations on your own. Let's look at number 13. 13 is strange and somewhat confusing. If 8% of patients that get tested for HIV actually have HIV, and the test is 95% accurate, what's the probability that a positive test result is accurate? So let's break this down real quick. Let's pretend that 1,000 people got tested. Well, 8% of the patients that get tested actually have HIV. So that means out of 1,000 people that got tested, 8% of them had HIV. So 8% of 1,000 is 80 people. So 80 out of 1,000 actually have HIV. The test is 95% accurate. So what is the probability that a positive test result is accurate? So if it's 95% accurate, okay, then that means that the other 920 people that were clean ,95% of those came back and said, yeah, you're clean. Well, that means 5% of the clean, the test came back and said, I'm sorry, you're not clean. Those were the ones that were inaccurate. So the 5% of 920 is how much? That would be 46 people. 46 of the 920 were wrongly accused of, falsely accused, they were false positive. That means they didn't have it, but the test said they did. So those are 46 inaccurate results. On the other hand, out of the 80 that did have it, 5% of them came back and said, you don't have it, when they actually did. Well, what's 5% of 80? That would be 4 people. So 4 were false negative. In other words, they had it, but the test said they didn't. So 46 said they had it when they didn't, and 4 said they didn't have it when they actually did. Now the question asks, what's the probability that a positive test result is accurate? Well, how many positive test results came back? 46 of the clean ones came back positive. The other 76 came back positive. So 46 plus 76, that comes out to 122 people got a positive result. Now, only 76 of those were actually correctly positive. The other 46 were positive, but they shouldn't have been. So the question asks, what's the probability that a positive test result is accurate? So the 76 were accurate. Out of the 122 that all came back positive. So the probability would be 76 divided by 122, which comes down to, well, only reduces to 38 over 61, which is approximately 0.62%. So 62% of the time, if you got a positive test result, it was right, according to these tests. All right, number 14. There are 3 styles of letter jackets. We want to figure out how many choices and how many different combinations there are for the letterman at the school. Well, there's 3 styles, and each style comes in 4 colors for the sleeve, and there are 2 options for the color of the body, and there are 14 different letters that they can put on depending on which activity. And so if we multiply all those together, 3 times 4 is 12, times 2 is 24, so 24 times 14, I'm going to need a calculator for that. 24 times 14, I'll let you do the calculations. That's going to be how many different combinations this company is going to have to possibly create. On the multiple choice, the only one that you may not have is event. Event is a subset of a sample space. Disjoint, those are the ones that have no outcomes in common, where the occurrence of one all right, time out, let's see. The situation where the event does not occur, that is, all right, where is all my answers? Something may be wrong with this matching. The event does not occur, it's supposed to be complement. Instead of all possible outcomes of a random phenomenon is going to be the sample space. Okay, so we got that one. The event where the occurrence of one has no effect on the probability of the other, that's going to be independent. Okay, so we got that one. We got D. Any possible result of a random phenomenon, that's an outcome. An event that has a probability of 0, that's impossible. An event that has a probability of 1, that's certain. A number between 0 and 1 that represents the likelihood of an event, that would be the probability. So disjoint is not quite A. So this one, I guess I must have put the wrong definition here. There's no definition for disjoint up there. That would be events where the occurrence of one does or has an effect on the probability of the other. All right, moving down to number 16. How many different ways can the letters A-R-G-I-S-H, Argish, be arranged into a 5-letter string if the letters can be repeated? Now we have 1, 2, 3, 4, 5, 6 different letters. How many ways can they be arranged in a 5-letter string if the letters can be repeated? So if you can repeat them, well, there's 6 ways for the first, 6 for the second, 6 for the third, 6 for the fourth, and 6 for the fifth, which is 6 to the 5th power. I'll let you do the math on that. If you cannot repeat the letters, then there is 6 for the first, but then there's only 5 for the second, 4 for the third, 3 for the fourth, and 2 for the fifth. And I'll let you do the math on that. In the game of spades, number 17, 13 cards are dealt from a standard deck of 52. How many hands are possible? This is going to be a big number. This is going to be a combination because order doesn't matter. So you're going to use the combination formula in your calculator. We are going to have 15 to choose from, or 52 to choose from, and we're going to choose 13. So your calculator will probably give you a number with an E. That's in scientific notation, so don't put E, put times 10 to the whatever that comes out to be. Round it to the nearest hundredth power. 18, the senior class has 348 students. There are 5 different offices. How many possibilities are there for student council offices? Well, this time order does matter, so it's going to be a permutation. Out of 348, we're going to choose 5. So again, put that in the calculator and figure out what it comes out to be. If it's written in scientific notation, don't put the E, put something else. On 19 and 20, just put these in your calculator. Now, you could write this as a combination because it matches the combination of formula. It's a combination from 32. We're going to choose 15. That would be the 2 numbers. On number 20, this matches the permutation. Out of 19, we're going to choose 7 minus 19, so it would be 12. I believe that's right. It's getting late. My brain stopped working about 10 minutes ago. Last, how many ways can the letters in the word quantitative be arranged? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 different ways. So that would be 12 factorial if they were all different. But they're not all different. We have 1, 2, 3 T's. We have 1, 2 I's. And we have 1, 2 A's. Is that all? 3 T's, 2 I's, 2 A's. We have 1 Q, 1 U, 1 N, 1 V, and 1 E. So we would need to divide that by 3 factorial times 2 factorial times 2 factorial. Make sure you put that in parentheses if you're doing it on the calculator.